writing equations of a line, it's got, I think, 2 or 3 different ways that we could do this. So the easiest one is y equals mx plus b. So I'm going to do a little quick side note. I'm sure y'all already know this, but m is slope or rate of change, whatever you want to call it. Okay, and then b is the y-intercept. Just put y up front, y-intercept. And it'll be written as 0, comma b. Okay, and b will be the y-coordinate. All right, so from this, we'll be able to do linear lines. That's the straight line that we can create. We can also put this in standard form. So we have y equals mx plus b, and then we have ax plus by equals c. Now, c, b, and a are just constants. Okay, there'll be something in there, some number that'll be in front of them. And then x and y are your variables, okay, because there's only x and y coordinates. So standard form of a line, might make a little side note right there that this is standard form. This one here up top was the slope-intercept form. They're really easy to identify because it's the things that are in the equation. Okay, so you'll have slope-intercept form, and then you'll have point-slope form. That's the ones that are easy to identify. And in standard form, all of the variables are on one side, and the regular numbers will be on the other. Okay, variables on one side, regular numbers on the other. Okay, so let's do example 1. Writing an equation in standard form. They give us this example. It's the conversion to Fahrenheit. So Fahrenheit would be 9/5 of Celsius plus 32. So what it will ask us to do is either convert this. This is in y equals mx plus b form. This variable equals constant times a variable plus a constant. Look up here. Same concepts. Okay, it's just different variables. So on this one, it's already in y equals mx plus b. It's going to ask us to put it in standard form. So in order to put this in standard form, we need to get all the variables to one side and all of the constant things without variables to the other. Okay, so in order to move all the variables to one side, I'm just going to move or subtract 9/5 c from both sides. Just because it's a fraction doesn't make it any harder to move. We can just do that the same way we normally do. So those go away. I'm left with just 32 on this side, and I have Fahrenheit minus 9/5 c. A lot of people get stuck right here and go, I don't know what to do. Just rewrite it down. You don't have to do anything. Okay, just rewrite it down. All right, so from that point, this is pretty close to standard form. Standard form is not in fractions, though. Okay, so there won't be any fractions. So I have to find my least common multiple to multiply this whole thing by, so that I have no fractions. And what my least common multiple be for this guy to make everything whole numbers. Same as my least common denominator. 5. Easy enough. It really is 5. Just distribute it out. So I have 5f minus 5 times 9/5 will give me 9c, and then 5 times 132 should give me like 160. Okay, thank you. And that's it. That's standard form right there. So this is standard form. Kramer's rule is to find the values of the variables. Yes, but you need 2 or more equations. If you have 2 variables, you need 2 equations. If you have 3 variables, you're going to need 3 equations, etc. So we follow that rule. Okay, going on from here, reminder, I'm just putting this little side note that we have slope-intercept form to start with, and then we ended up correcting it down into standard form. Okay. Next example will be example 2. Example 2 gives us the equation y equals 3x plus 7. Okay, so I'm going to do a couple of conversions with this one. Okay, I'm going to convert this one to standard form. So in order to do that, I have to move my 3x. So here if I look back at my standard form, notice that x is first and y is second. Okay, so I'm going to put that in the alphabetical order. So if I look back up here and I'm looking at alphabetical order here, I would need to rewrite this as negative 9c plus 5f equals 160. Okay, so alphabetical order would put that there. But especially when we see x and y, we try to run our x up front and our y second so that we have that form. So minus 3x on both sides. I have negative 3x plus y equals, that cancels out, just my 7 dropping down, and I'm good there. Okay, so this is standard form. Everything is already in integer or whole numbers. Okay, so I'm good there. These are just a constant. Just a constant is 1 there, constant 7. So there it is into standard form. Now, what the original problem asks us to do, it says that we have a line with slope 3, so m equals 3, and a point of 0, 7. Okay, so they give us a point and slope. So we're going to use point slope form. Point slope form is very nice for any time that they only give you limited information, slope and a point. Okay, so that's how you'll know where to use it and when to use it. So point slope form is this equation here. It's y minus y and m open parentheses x minus x. Okay, so where this comes from, let me show you where it comes from. This is slope. This is the equation for slope. Watch. This is m multiplied by x minus x, right? So this x minus x, if I divide it to both sides, I get m equal to the difference in y's over the difference in x's. It's exactly the same as slope. But they put it in point slope form so that when you plug it in, this is point slope form right here, so that when you plug it in, it makes a really nice equation for you. So let's plug these points into the equation and see what happens. So I'm going to take y minus my y sub 1, okay, so this is my y sub 1, y minus 7 equals my slope of 3, open parentheses, x minus 0, which is kind of pointless, right? So now I have y minus 7 equals 3 going into that, 3x, and I don't really need to worry about that, that's just 0. And then I just add 7. So y equals 3x plus 7. Okay. Any questions there? So you now have 3 equations. You have point slope form. Okay, you have this guy right here, point slope form. You have slope intercept form. I shouldn't have said equations, I meant forms. And then you have standard form. So you have 3 different ones that you're going to need to know and use, and how to convert from one to the other. Point slope form is really nice because I can get to y equals mx plus b really quickly. But if I wanted it in standard form, I could also get that to standard form rather quickly. All I'd have to do is one more step, subtract 3x, right? Which is what we did up here. So it's all pretty much tying into one another. All right, so example 3, we'll move on from there. Example 3 is using this point slope formula a little bit more. So using my point slope formula, it has to come with first a point, then a slope. Okay, so in example 3 it says a line has a slope of -2, so I'm just going to write that down. Slope of -2 and a point 10, 12. And then I just plug into my equation, and from there I can solve it for whichever method they want me to put it in. So let's see, it says what is the equation of the line written in slope intercept form? So we start plugging in y minus my y, which is 12, equals m open parentheses x minus my x close parenthesis. So start to distribute out my -2x, my -2 to a -10, which is a +20, and that's where most of the mistakes will be made. Make sure that negative goes to both sides of that, or sorry, both of the numbers inside, not out. Okay, so moving from there, I start to simplify. It's y equals mx plus b, so I'm going to add 12 to both sides. Y then will equal -2x plus 32. Questions? It's really just plugging and chugging, guys. You just plug and go, plug and go. Okay, example 4, and it is the final example. Oh, no, we'll do number 5. We will. Sorry. Example 4. It gives us a few things. It says writing the equation of a line given 2 points. So inside of there, it gives us units sold as 1,000. So there's 1,000, comma, and then it says amount before you break even was negative 5,000. So that's 1 point. Okay. My second point is 2,000, 2, 3, comma, negative 2,500. So I now have 2 points. And from 2 points, I can find what? Slope, right? It only takes 2 points to make a line. So from these 2 points, I can find slope. So remembering that our equation for slope, which we just used, was difference in y's over difference in x's, I'm going to start out doing that. So I have negative 5,000 minus negative 2,500, which I need to correct to be a plus, right? And then I take my 1,000 and I subtract my 2,000 and just find my slope rather quickly. Okay, I have negative 500 plus, or sorry, negative 5,000 plus 2,500, which is negative 2,500, and 1,000 minus 2,000, which is negative 1,000, and those will end up canceling out, and those negatives will end up canceling out. So I have 25 over 10, and I can continue reducing this. I'm going to reduce it by 5, so I get 5 halves. So my slope is 5 halves. So I now know my slope is 5 halves, or 2.5, whatever you want to use. I'll use 2.5. Okay, so I now know my slope. From here, I can use what form? I have slope-intercept, and I have point slope. Point slope, right? Because I have a slope and I have a point. Now, it doesn't matter which point you use. It doesn't make a dang bit of difference. You're going to get the same exact equation. So just pick whichever one is going to be easiest and use that one. I'm going to use their third point because I think that's going to be really easy. Their third point was 3,000, comma 0. I think that's going to be easy because of the 0. Okay, so y minus 0. So blam. I don't have to even write down that. No point. Okay, so y minus 0 is just y, so I just wrote it down. And then I have my slope, 2.5, and open parentheses, x minus 3,000, 1, 2, 3. Okay, and just distribute. That's all that I have to do. So I get 2.5x minus 2.5 times 3,000. I do not know what that is. 7,500, is that right? I think it is. Yeah, 7,500. So that is the equation of that line. Find slope, plug it in to a point, and choose the easiest point. Always try to make your life easy if you can. Okay, any questions there? Didn't figure you would. Example 5, and last example for real this time. It gives us another set of data. So it gives us age of 2, a height of 35, age of 3, a height of 37.5, age of 5, height of 42.5. And then it asks us to find something specific, right? The Centers for Disease Control has developed growth charts that pediatricians use to see if a child's height is within a certain average. The chart that I just described shows the data for a boy's height in the 50th percentile, which just means average. 50th percentile means average. The 3 points lie on the line. Use the data to write the equation of the line in slope-intercept form. Okay. Slope-intercept form is y equals mx plus b, so we're going to use a couple of their points, 2, 35 and 3, 37.5. And I need to find slope. So slope will be the difference in y's. So I'm going to take 37.5 minus 35 over my difference in x's, which is 3 minus 2. I get 2.5 up top. I get 1 on bottom. So my slope is again 2.5. Lucky us. Okay, so since my slope is 2.5, I'm just going to start plugging it into my y minus y. And it doesn't matter which point you use. Again, I am going to use my 2, 35, since those are whole numbers. So y minus 35 equals my slope of 2.5 open parentheses, x minus 2, and I start to solve. So distribute out my 2.5, I get 2.5 x minus 5, and then I just drag this little bit down, get rid of my 35 off of this side, so I'm adding 35 to both sides, and y equals 2.5x, just dropping that down, plus 30. Questions? Okay, that was it, guys.